There are many ways to tackle these inequalities. I'm not going to go through all of them, and this may vary slightly from what they're teaching you in ALEKS, but there's a couple things I do know that are consistent. Whatever the inequality is, you definitely want one side to have a 0 on it, for sure. So if you get a problem that's not like that, your first step should be to make the one side equal 0. The second thing is, we're going to start off by finding out whether this function is either 0 or undefined. And I realize you guys don't have all the experience to necessarily make that a simple instruction, so let me just tell you how you figure this out. A function is 0 anytime the numerator is 0. So we're going to figure out what makes the top of the function 0, and that's going to be what we call a point of interest. Functions are undefined, as you guys do know from this class, if the denominator is 0. So to kick this problem off, we're just going to look at what makes this 0 and what makes this 0, and those will be our points of interest. So it's pretty simple in this case, I think, to see that our points of interest are going to be -2 and, I was going to do this in my head, but there's a lot of negative signs there, so just to be safe, I'm going to do this off to the side over here. -6. I mean, I did know that, but I just want, in case anyone else needed to see that, that's what happens. All those negative signs, be careful. People mess those up. So there's no shame in doing work off to the side. So what we're going to do next is put these on a number line. And the general idea is that, we have a division problem. We want to know when things are greater than or 0. So that basically means we want to know when this entire expression is, in this case, positive. If this were less than 0, I'd want to know when this entire expression is negative. And what we're going to do is use our rules for division and the signs to figure out what's going on. Like, for instance, you guys know that a positive divided by a positive is always positive. You know a negative divided by a negative is always positive. You know a positive divided by a negative or a negative divided by a positive is always negative. And the thing is, these expressions that we looked at over here, they can only change signs at these points of interest. This is basically going to always be, this is either going to be positive or negative, one or the other, and it's going to, if it changes signs at all, it's going to happen after it turned to 0. This also will always have to be positive or negative, and if it ever does change signs, it's going to happen where that thing is 0. So that's why we start off by figuring out what makes this 0 and what makes that 0, because that's where the signs can change, and if the signs change, then we'll know if the overall division is positive or negative. We're doing this thing called sign analysis, and it's a pretty important skill for moving, like once you move forward into calculus, hopefully your senior year. So here's the next part. We find these points of interest, we put them on a number line. We know that I will say one thing, since this is greater than or equal to 0, and this makes the entire thing equal 0, like whatever makes the numerator 0, if you have a greater than or equal to 0, that number is included in your answer. So there's definitely a closed circle here. If it made the denominator 0, regardless of what this says, it's always an open circle, because you can never ever allow this denominator to be 0. So, we don't want to include it in our answer. It's always open. To recap that idea, just to say it one more time differently, the number you get from the denominator will always be an open circle. The number you get from the top will be an open circle if you're dealing with this or this. It'll be a closed circle if you're dealing with this or this. Alright, so moving on, what we're going to do next is these 2 points of interest have broken the number line up into 3 separate regions. And I'm going to do this thing where I just pick a number from each region. I'm going to plug it into the original expression. And all I'm really looking at is the sign of the number. I don't really care about the value. And we'll just see what happens. So for instance, if I take, let's do all this in green. If I pick a number from here, now some of you guys might pick -7 or -10. I'm going to pick -1 billion. Just something really huge. And here's what I'm going to think to myself. If I take -1 billion and I add 2, it's still negative. If I take the opposite of -1 billion, that's going to be positive. And I'll subtract another 6, it'll be positive. If you don't like that, just pick something small like -7, and you'll see, like, okay, if it was -7, I'd have a -5 over -7 is 7. 7 minus 6 is 1, so I have a negative over a positive, so ultimately this will be negative. We found the sign of the top, we found the sign of the bottom, and we know the division of those things produces a negative answer. On the other extreme, let's go to this guy, this part over here. Let me pick a huge number like 1 billion. You know, I'm just thinking positively huge. Positively huge plus 2 is still positive. The opposite of positively huge is really, really negative. Subtract 6 from that, it's still negative. So now I have a positive over a negative, which is going to ultimately be negative. And again, if you don't like that, pick a number like 0 or -1 or 10. Let's say I picked 0. You'd see that you got 0 plus 2 is 2. Negative 0 minus 6 is -6. You have a positive divided by a negative. It's negative. You'll notice, again, I don't care about the value. I care about the sign because I'm just interested in its relationship with respect to 0. Now, excuse me. Now, for this middle part, there's no shortcut here. You have to actually pick a value and do something. So any number between -2 and -6, I'll pick -3. So -3 plus 2 is -1. -3 is +3 minus 6. So we have -1 over -3. We have a negative over a negative. That'll ultimately be positive. So everything in here will be positive. So just to give a clean version of what's going on here, the numbers that are going to actually work are going to be the ones between -6 and 2, including 2. And in interval notation, that's going to be open circle on -6, so rounded bracket, and then 2 with that thing. That'll be my final answer. And if it's not clear why, it's because we were looking for the places where this expression was bigger than 0, which means we wanted the place where we got positive answers. To switch things up just a little bit, let's say it had been less than 0. If that had been the original problem, then I'd want all the places where it was negative. So then my answer would have been all of these points over here, all of these, and all of these. And just because, like, so let's just say the problem had been x plus 2 over -x minus 6 less than or equal to 0, and I'd want those red regions. In interval notation, that would be from -infinity to -6, don't include -6, then this big union symbol from include -2 up to infinity. So, and we would have picked those because that's where it would have been negative, and that's when, if it's negative, it's less than 0. So that's the basic thing. We're going to figure out the zeros at the top, the zeros at the bottom, decide if the numbers that made the top 0 are included or not by looking at the symbol that was given to us, do some sign analysis, and at the end of the day, just give the interval notation at the end. Good luck.